Hello guys, this is a circle geometry question from a BARKER 2012 exam we've been doing. It's extension 1, semester 1. So keeping in mind we want to be in the bar before 7:30, I'll move on, shall I? So two circles intersect at points A and B. So we've got this little circle and a big circle, and there's points A and B where they intersect. The diameter, so this is important, the diameter of one circle is CA. So this here, I'm using a normal pen on a real paper, on an electronic paper. How stupid do I feel? Alright, anyway, so AC is the diameter. So that's important. Remember that, of this little circle. And this line intersects at P over here. The line CB, which is this little one, intersects the circle, the second circle at Q. So that's all we need. So that's just explaining what's going on. But the main take home out of all of that is that AC is the diameter of this little circle. And we need to prove that CPQ, so that's this angle just here, we need to prove that this is a right angle. Beautiful. So that's what we're going to prove. So we're going to start off with something called Thales or Theorem, or Thales, depends how you say it. And this was, Thales was an old Greek boy, 624 BC to 546 BC. And a lot of people think that Western philosophy started with him. Like he's the first kind of person who, before that, people had ascribed like the causes of things in the world to like gods, like the whim of God, saying, oh, you know, that's just God being angry, that's why there's a storm, and so on. And he was the first person to kind of say, you know, maybe there's an answer that's not supernatural. Anyway, something he realized was if this is a diameter, so similar to what we've got in AC over here, so say that's A and this is C. Any point that you draw with AC as the basis of the triangle will be a right angle. So this is called Thales' theorem. And what we can use that to infer is that when this AC here is obviously the diameter, as I've mentioned a million times. Oh, that is my phone ringing. Hang on. Sorry about that. So this AB is... so we've got a right angle there. So because, according to Thales' theorem, that ABC is a right angle, according to Thales' theorem. Now, that also means that because this is a right angle, then this little bit here is also a right angle, because, you know, just using you know, supplementary straight lines have an angle sum of 180 degrees, and there was 90 degrees here, so this also has to be 90. So now we've got this little quadrilateral I want you to focus on. APQB. And we're going to introduce a new topic, a new kind of theory now. And it's that opposite angles in cyclic quadrilaterals are supplementary. So what that means is we've got this circle here and a cyclic quadrilateral in it, which just means we've just got 4 points, a quadrilateral that is on this circle. And the fact that the opposite angles are supplementary means, you know, something like this A here is 100 degrees. If it was, then this would have to be 80, for example. Or if this was 110 degrees, then this would have to be 70, because opposite angles are supplementary, meaning they add up to 180. So now, using what we know here, this is, we know this is 90, and then therefore this has to be 90, because this is the opposite angle in a cyclic quadrilateral. So my first step, I would write angle ABC is 90 degrees, and then I'd say Y, Thales' theorem. Beautiful. And now, it might not be called Taylor. Oh, go away, my phone just keeps ringing. So I'm going to turn it off next time, won't happen again. And then, so a second one is, of course, that this opposite angle theorems. Oh no, then I'd probably state therefore angle ABQ equals 90 degrees, and then I'd just say supplementary. Wonderful. And then thirdly, what I'm going to do is say therefore angle, then what did they want? They wanted CPQ, so that's this one. CPQ equals 90 degrees. And then for my reason, I would say opposite angles in a cyclic quadrilateral are supplementary. Beautiful. So that's the question done. Sorry for all these phone calls. Have a good one. I'll see you in the next one.